Okay, in this second special cases factoring video, we're going to be looking at perfect squares. So when we end, they're going to look like this, either a plus b quantity squared or a minus b quantity squared, and what a and b are will vary. But that's the way they'll end up. Okay, so that's what we're looking for with these patterns. So in order to identify the patterns, first off, there'll be trinomials if they're perfect squares that will factor that way. And we need to make sure that the first term and the last term have perfect square roots. If they do, then it's likely that, or it's possible, I should say, that it has a perfect square pattern. So instead of going through the pattern this time, we're going to factor it as we normally would. So it's a trinomial, leading coefficient is 1. I do see this has a perfect square root of k, so let's write that off to the side, and this has a perfect square root of 1. So let's see if it works out. So we have a trinomial leading coefficient of 1, so we're going to put our x on our paper. We want to multiply to the last number and add to the middle number, so negative 2. So the factors of 1 are only 1 and 1. This is a positive number, so they both have the same sign, and they'll both be whatever sign this is, so there it is. So it would be k subtract 1 in one parentheses, k subtract 1 in the other. The correct way and most simplified way to write this is k subtract 1 quantity squared. That's called quantity squared. So you're taking this whole quantity and you're squaring it. So this is equivalent to this. And notice the square root of k is here, the square root of 1 is here, and in this case we're subtracting them. Okay, another example here looking at the perfect square pattern. So we said to be one of the perfect squares so that it finishes with factors like this or like this, where it's a quantity squared, either adding or subtracting, we need for the last number, so the last term I should say, to have a perfect square root. Well, that's a 5. And the first term has to have a perfect square root, so that would be a 2k. If that's true, it's possible that it is a perfect square. It's not enough to say that it's a perfect square. It might be. So we'll talk about the full pattern in just a minute. So let's work through this. So we're going to multiply this like we normally would. We look for a greatest common factor. There isn't one there. So we'll do first times last. So we get 4k. 4 times 25 is 100. We want to multiply to 100. We want to add to the middle number, negative 20. So we want factors of 100, and we're going to shortcut this a little bit. It's going to be 10 and 10. So 10 and 10 here. I have a positive number here, so both of these are going to be the same, and they'll both be this sign right here. So they're both negative. So then I need to split it into two pieces, just like we did last time, because the leading coefficient is bigger than 1. So 4k squared, subtract 10k plus 25. Now, greatest common factor out of those, so we're grouping these up. So that would be a 2k greatest common factor. We'd be left with a 2k subtract 5. Group these two. Greatest common factor there would be a negative 5. Take that out, you're left with a 2k subtract 5. So put those together. 2k subtract 5, that's these two together. And then the matching parentheses gets written once. So that would be also 2k minus 5. And as discussed, the proper way to write that is 2k minus 5 quantity squared. And if you notice, perfect square root there, perfect square root end up being the two terms inside the factor. Now, here is the pattern that we are looking for. It's going to be this, and this pattern is a squared minus 2ab plus b squared. Okay, that's the pattern. So we have something squared here, something squared here in the last place, and if you take those two and multiply them together, plus multiply them by 2, you'll see that we'll get that pattern. So let's do that. So in this case, our a value in our pattern, our a value is the 2k, our b value is the 5. So let's see if that works. So we square the a value, so that's 4k squared, check. Subtract 2 times the a value of 2k times the b value of 5, and then we add the b squared. Well, that our b value is 5, so 5 squared is plus 25. Now multiply all of this out, so it would be 4k squared, subtract 2 times 2k is 4k, times 5 is 20k, and we're subtracting it, plus 25. Check, so the pattern works. So I don't really care if you know this pattern or not. I just want you to be aware to be on the lookout if you have 3 terms and the first term and the last term have perfect square roots. It's possible it's going to end this way, but you can just factor it like you normally do and see this. Later on, maybe in an Algebra 2 or a pre-cal class, you'll want to be on the lookout for this pattern and jump straight here. But for now, factor it like you normally would. Just be on the lookout for this special pattern and make sure you write it this way as a perfect square. Okay, 21's a little different. You notice that we have plus plus in the pattern, or in the trinomial, and up here we had subtract a minus plus and a minus plus. So this time we have a plus plus. So let's see how this is going to work out. Now you can factor it just like this. It's not going to matter. But we are going to go ahead and rearrange that. So we're going to write it as 25k squared plus 20k plus 4. That's always okay to do. So we're going to look at it this way. So if we possibly have the perfect square format, we need 3 terms, okay, check. And we need this to have a perfect square root. It does. 5k is the perfect square root of 25k squared. And this one needs a perfect square root. Perfect square root of 4 is 2. So maybe it will be 5k and 2 in the factor. We'll just have to work it out and see. So we look for a greatest common factor. We don't have one. So we multiply first times last, since this leading coefficient is bigger than 1. So that would give us a 100 that we need to multiply to. We want to add to 20. We've had this same setup before, so it's 10 and 10. Okay, you would just do all of your factors of 100. We didn't do it last time. Let's do it. 1 and 100, 2 and 50, 5 and 20, and then 10 and 10. And the only one that will combine to a 20 is the 10 and 10, and they both happen to be positive here. So we're going to split this into 2 pieces, 25k squared plus 10k plus 10k plus 4. Remember, these 2 numbers go here with the variable. Now we group them. That would be a 5k as the greatest common factor, left with a 5k plus 2. Greatest common factor here would be a 2, so plus 2. And we're left with a 5k plus 2. So all together, we take the 2 outside the parentheses, put those together, and we write the matching parentheses one time, 5k plus 2. And it worked out. These were the 2 numbers in our factors. Now notice the pattern here. They're both addition. So this is our final answer, 5k plus 2 quantity squared. Before we had our factors were subtracting in the first 2 examples. So it can be either way. The pattern can be either way. In this case we had plus plus in the beginning, so we ended with plus plus here. In the previous 2 examples we started with a subtract plus, so we ended with both of them being negative. And that pattern will hold. Alright, so that's it for this video.